tell you something that might surprise you. The most frightening place in the universe is not a black hole. It is a place where almost nothing happens at all. A darkness that does nothing. Think about that for a moment. We imagine cosmic danger as something violent. Black holes tearing stars apart. Spirals of glowing gas. Beams of light. They sound like the villains of the universe. They crush, they stretch, they devour. It feels natural to say that must be where the real terror lives. But here's what we do know. Most black holes are not actually black. When they are feeding, they are wrapped in bright disks of matter, hotter than almost anything you will ever experience, lighting up the space around them. If you fell toward one, your story would be brief and dramatic, painful, yes, but full of events, full of change, and in a strange way, a story that ends is still a story. Now imagine something quieter. Imagine drifting, not toward a black hole, but into a vast cosmic void, a region so empty that across hundreds of millions of light years there might only be a thin scattering of lonely galaxies. In a place like that, nothing tears you apart. Nothing pulls you into a bright, catastrophic ending. You just float. Only distance, only delay. No rescue, but also no final act. Just more waiting, stretched over more time than any human word can comfortably hold. That emptiness, in its own quiet way, may be more unsettling than anything that could ever destroy you. It is so simple, it is almost funny. The universe's most disturbing places may be the ones that barely do anything at all. But tonight, we're not in any rush. If you like, you can lie back. Let your eyes close or rest them on the ceiling or on the dim numbers of a clock by your bed. You do not have to watch the screen. You do not have to remember anything. Just let the words drift by, the way distant lights drift past a window on a very slow train. We're going to walk through this slowly, starting from the familiar glow of city lights and bedroom lamps, out to the soft darkness of your local night sky. From there, through the crowded disk of our galaxy, along the threads of the cosmic web, and into the enormous dark bubbles between them. And then, a very long time from now, into a universe where that stillness has grown almost everywhere. Some of it is going to be strange, some of it is going to be beautiful. But you do not need to hold on to any of it. You can let each fact arrive and then let it go again. The pace will be unhurried, the story will be quiet. And all of it is here simply to give your mind something gentle to wander through as we follow the trail from bright, violent darkness to the places where darkness barely bothers to move at all. So let me tell you where we begin. Not in a black hole, not yet, but with something you already know very well. A quiet night, you step outside, you look up and you see darkness. Or at least that is what you call it, a dark sky, a black sky, a ceiling of nothing. But stay there for a moment, because the longer you look, the less empty it feels. Points of light begin to crowd your vision. Bright, sharp stars, a wandering planet with a steadier glow. A pale, milky band stretching across the sky, which is your own galaxy seen from the inside, a river of hundreds of billions of stars that your eyes smooth into a soft cloud. Even between the stars, where you think there's only black, there is still something. Think about that thin, in-between darkness. Out there in the space between suns, stray photons are rushing past, left over from exploded stars reflected from dust, scattered by gas. The dust itself can glow very faintly, warmed by distant starlight, like embers that have almost forgotten they were once part of a fire. And underneath all of that, everywhere, all the time, there's a background, a faint microwave glow, the afterimage of the Big Bang, filling every direction. You cannot see it with your eyes, but the universe carries it the way an old photograph carries a memory of a very long time ago. So even what you casually call empty space is full of light. if you have the right kind of patience and the right kind of instruments. Now, when people think of the ultimate darkness, they usually jump straight to black holes. A hole in space that not even light can escape. From far away, you imagine a perfectly black circle carved out of the stars behind it, a place where the story simply stops. But here's what we do know. If a black hole is feeding, if matter is falling toward it, the region around that dark center can become one of the brightest things in the universe. Gas spirals in, forming an accretion disk, a flat, swirling ring that heats up until it shines in X-rays and ultraviolet light. It is so simple, it is almost funny. The thing you fear for its darkness announces itself with a blazing halo. Even the black hole itself is not perfectly silent. According to Stephen Hawking's idea, there's a faint trickle of radiation at the edge where quantum effects let a little energy leak away. Over an unimaginable span of time, this Hawking radiation would let the black hole slowly evaporate. So the darkest object in your imagination is still interacting, still changing, still part of the universe's bookkeeping. So if the night sky is not truly dark, and even black holes glow and whisper their presence into space, then what would it really mean to talk about the darkest place in the universe? What does darkness look like when almost nothing is left to shine or even to fall? To answer that, you have to sit for a moment with a very strange idea. Not a place full of things, not a place where stars explode or where black holes tear matter into glowing spirals. A place where almost nothing happens at all. Astronomers have a phrase for this, and let me tell you, it sounds deceptively simple. They call it a cosmic void. Not a perfect vacuum, not an absolute nothing, but a region of space where there is far less matter than average. Far fewer galaxies, far fewer stars, often no bright planets at all, just a very thin mist of atoms spread over distances so large that the numbers barely feel real. Think about what you already know. You know what a star is, a ball of hot gas burning through its fuel. You know what a planet is, something solid enough that, at least in principle, you could stand on it. You know what a black hole is, a place where gravity is so strong that even light has trouble escaping. Those are things, they have edges, surfaces, temperatures. You could, in a very dramatic way, fall into them. But emptiness is different. Emptiness does not pull you in. Emptiness does not reach out. Emptiness just fails to show up. Here's what we do know about the large-scale shape of the universe. If you could step far enough back, much farther than any real telescope can, you wouldn't see a smooth fog of galaxies spread evenly in all directions. You would see a kind of web, thin, bright filaments where galaxies cluster together in long chains and sheets. And in between those filaments, enormous dark bubbles where the density of matter drops away. Those bubbles are the voids. Some are 10 million light years across. Some are 100 million. There is one, the Bootis void, that stretches for roughly 330 million light years, and in all that volume you find only a tiny handful of galaxies where you would expect hundreds or thousands. It is hard at first to feel anything about that other than mild curiosity. An interesting pattern, a piece of cosmic geometry. But if you stay with it, slowly another layer appears. Because these empty regions are not just gaps in a picture. They are part of the story of how the universe has been expanding and thinning out since a very long time ago. They tell us that on the largest scales, isolation is not an accident. It is built into the architecture of space itself. And that's where the idea becomes uncomfortably personal. When you think about loneliness, about the fear of being cut off, you're usually thinking on human scales, one room, one city, one world. The cosmic void is that feeling written in units of millions of light years, and some of it is going to be a preview of the far future when galaxies drift apart and the web itself fades. Imagine then a place so empty that if the Milky Way were floating alone in its center, your night sky would show only a few faint smudges or perhaps nothing at all. Imagine doing astronomy there and concluding with perfect quiet confidence that your galaxy is the only island of light in existence. And now imagine discovering you were wrong. If that imagined astronomer in the dark were you, there's one small mercy. We are not going to leave you there all at once. We are not in any rush. This is not a fall into a black hole, with everything happening at once in a blur of tidal forces and panic. This is a slow walk, a careful crossing of the universe, where you have time to look around, to let each new emptiness settle in your mind before we move on. So let me tell you how we are going to do this. We will begin a very long time ago when there were no galaxies at all. Just a hot, bright, almost perfectly smooth sea of light and particles, still echoing in what we now call the cosmic microwave background. In that early world, the darkest places were not yet voids. They were tiny, slightly cooler patches, little dents in the smoothness, born from quantum fluctuations that we honestly don't know for certain in every detail. From there we will move forward slowly, as those dents deepen under gravity. Think about matter flowing, the way rainwater finds valleys, trickling at first, then carving channels, then rivers. Over millions, then billions of years, thin filaments of galaxies will grow, walls will form, and between them the first real cosmic cavities will open, regions 10, 50, 100 million light years across, containing only a fraction of the galaxies you would expect. Our journey will follow a single thread through all of this. The thread is an idea, cosmic emptiness. We will touch it in the space between stars in our own galaxy, where a few lonely atoms drift in each cubic centimeter. We will see it in the wide gaps between galaxies in a cluster. And then we will zoom out again and again until that same idea stretches to the scale of the Boötis void, a bubble roughly 330 million light years across, where almost nothing shines at all. Along the way, there will be payoffs, moments when something that once sounded like an exaggeration suddenly becomes the only explanation that makes sense. Why some patches of the sky in deep surveys look strangely underpopulated with galaxies. Why an observer sitting in the middle of a large void might build an entire astronomy on the mistaken belief that the universe ends just beyond their own few smudges of light. And all of it will stay gently tied to your own experience. Just as you can pinch and zoom on a map, moving from the familiar pattern of your city streets to the outline of a continent, we will zoom out from the constellations, into the full cosmic web, and then keep going until even that web starts to look thin. Here's what we do know: if you give your attention time to match the pace of the universe, the horror and the beauty of its darkest places become clearer, not sharper, quieter. In the next part, we will take our first real step back in time to watch the light fade and the first shadows of true cosmic darkness appear. So before we let that darkness close in, stay for a moment where you are, on your back maybe, staring at the ceiling. The room is dim but not empty. There's the phone charging on the table, a little rectangle of glass and metal quietly trading energy with the wall. There's the roof above you, layers of wood and tile and insulation holding back the night air. There's the bed under your weight, the walls around you, the door, the floor, the streetlights outside painting pale shapes on the curtains. Each one a small island of matter and energy doing something. Think about how crowded your world actually is. The air in your lungs, the dust on the bookshelf, the wiring in the walls, the water in the pipes, the concrete in the building next door. Someone laid every brick, tightened every bolt. But all of it ultimately depends on a quieter fact. This region of space is generous. It has stuff. Our galaxy is not special in any dramatic way, but it is full. Hundreds of billions of stars, clouds of gas and dust, planets, comets, asteroids. invisible rivers of dark matter holding the whole thing together. The sun is only one star among many, and the earth is only one planet, but together they give you a surface to lie on and a sky to look up at. Even the thin dust between the stars, so insubstantial you could pass your hand through it without noticing, gives structure to the Milky Way. And the same physics that keeps your roof from falling on you is at work on those scales. The numbers in an engineer's calculation, the way a beam carries weight, the way pressure moves through a wall, are just local versions of the same gravity that pulls matter into long, bright filaments in the universe. Let me tell you, it is strangely comforting. The force that keeps you in bed is the force that shapes entire clusters of galaxies. More remarkable than fire, more remarkable than language even. Now imagine taking that away. Not the laws, just the ingredients. A cosmic void is what you get when you keep the rules of physics, but remove almost everything that can play the game. Almost no stars, almost no heavy elements, almost nothing you could use to build a phone or a roof or even a rocky planet. Just a vast region where, for a very long time, the universe forgot to be busy. To ease into that, do a small experiment in your mind. First, turn off the light on your phone, then the lamp. Then the street lights outside, one by one, until your city is dark. Now dim the sky itself, every bright star gone, every faint one gone. The Milky Way, erased. And then keep going. Turn off almost every galaxy in the universe, until what is left is not a crowded cosmic web, but wide, silent gaps between its threads. That emptiness, those deep voids, are where we are heading next, to see what it would mean to live where almost nothing ever happened. When astronomers finally dimmed the universe this way, not in imagination but in data, something strange appeared. There was a place where even the gaps between galaxies seemed to open into a deeper gap, a hole in the sky of galaxies. Let me tell you how someone found it. In the early 1980s, astronomers were slowly building a three-dimensional map of the nearby universe. Not just pretty pictures, but careful measurements of how far away each galaxy was, turning the flat night into depth. They pointed their telescopes toward the constellation Bootis, a quiet patch of sky to your eye, and wrote down galaxy after galaxy like addresses in a growing cosmic phone book. Except in that direction, the numbers began to thin out. Then they almost stopped on the map, where you would expect a mist of points. There was a vast, clean bubble. It was as if someone had taken an eraser to the universe and gently rubbed away nearly everything in one enormous region. This is the Bootis void, a roughly spherical volume about 330 million light-years across. Think about that. If the Milky Way were placed at its center, the nearest large galaxies would not be a short hop away. They would be so distant that, even at the speed of light, their glow would take hundreds of millions of years to arrive. Your night sky would not just be quiet, it would be almost blank. Here's what we do know about a region that large. On average, given what we see elsewhere, you'd expect thousands of galaxies to be floating inside it, each with billions of stars, each star with its own worlds. Instead, after careful searches, astronomers have found only a few dozen, not zero, but a tiny, lonely fraction of what ought to be there. So the Bootis void is not perfectly empty. There are galaxies drifting through that darkness, but they are like isolated villages in what should have been a crowded continent. In maps of large-scale structure, where clusters and filaments of galaxies trace out a cosmic web, this region shows up as an almost comical absence. It is so simple, it's almost funny. Draw where the galaxies are, and the horror appears as the place where they are not. Astronomers call this kind of region a cosmic void, and Bootis is one of the most extreme we've seen. It is an underdensity, a place where the universe seems to have relaxed away from itself, leaving behind more space than matter. And all of it raises an uncomfortable question. Why are there holes this large in the first place? How did a universe that began a very long time ago as something hot, dense and nearly uniform end up with gaps so wide you could hide thousands of missing galaxies inside? To really feel how strange the Booty's void is, we have to step back and watch the universe build its own scaffolding and then see where it forgot to build anything at all. So let me tell you something that sounds almost impossible. The universe, which now contains roaring quasars, tangled galaxy clusters, and the Booty's void itself, began by being almost the same everywhere. Almost. If you could have visited a very long time ago, just after the Big Bang, you would not have seen stars or galaxies or dark, yawning gaps. You would have found a hot, dense fog of matter and light, spread out so evenly that every direction looked nearly identical. No up, no down, no special place to stand, just an expanding fireball, smoothed to a precision that is in a way more impressive than all the later chaos. Think about a perfectly still pond at dawn. The surface is flat, quiet, almost featureless. But then a tiny insect lands or a leaf touches the water, and little ripples begin to spread. The early universe was like that pond, with one important difference. Its ripples came from the strange mathematics of the quantum world. On the smallest scales, even emptiness cannot sit perfectly still. Tiny random fluctuations in energy appear and disappear, like brief whispers in the fabric of reality. During a brief violent growth spurt called inflation, the universe expanded so quickly that these microscopic ripples were stretched to cosmic size. Ripples that once would have fit inside an atom were pulled out across light years. It is so simple, it is almost funny. The largest structures in the cosmos began as numerical noise in the tiniest places, where a fluctuation made the density just a little higher than average. Gravity had a head start. Those regions pulled in more matter, grew heavier, and over millions and then billions of years collapsed into galaxies, clusters, and the bright filaments of the cosmic web. Where the density was a little lower than average, matter drained away toward its richer neighbors. Those regions became the empty lanes between the great highways of galaxies. Given enough time, a slightly emptier patch could grow into a true cosmic void. Here's what we do know about that beginning. We can still see a faint afterglow from that hot, uniform universe bathing all of space in microwave light. It is called the cosmic microwave background, and it is like a baby picture of everything. In that picture, the temperature barely varies at all, only by about 1 part in 100,000. Warmer spots mark tiny overdensities, cooler spots mark tiny underdensities, bright futures and empty futures, already written in temperature differences too small for any human sense to notice. The Booty's void, and the other deep cavities scattered through the cosmic web, are the grown-up versions of those slightly cooler, slightly emptier regions. Nothing dramatic had to happen there. In a universe that began almost the same everywhere, they simply started with a little less, and over billions of years that small numerical difference in density was allowed to grow into a vast haunting absence. And all of it traces back to those first ripples on an almost perfectly calm cosmic pond, waiting for gravity to decide what would be crowded and what would be left nearly alone. If you zoom out from one of those lonely regions, you begin to see the other side of the story, because gravity was not just taking from the emptier places, it was giving to the slightly fuller ones. Think about a universe that is almost perfectly smooth, where every patch of space has nearly the same amount of matter, but not quite. One region has 1 part in 100,000 more than average. Another has 1 part in 100,000 less. That is all. The difference is so tiny, it is almost funny, but given enough time, that tiny numerical imbalance becomes destiny. Where there's a little extra matter, gravity pulls a little harder. More gas, more dark matter, more everything falls in. Where there's a little less, gravity pulls a little less, so matter slowly drifts away toward its richer neighbors. The dense spots become denser, the thin spots become thinner. And over billions of years, this quiet, patient process amplifies those first ripples into enormous contrasts between light and dark. Here's what we do know. When someone runs a computer simulation of the universe, they start with that almost uniform fog, seeded with those tiny variations. They let gravity and cosmic expansion do their work. At first, nothing much happens. The fog just cools and stretches. But as the numbers tick forward, structures begin to appear. Threads, knots, hollow spaces. What began as a gentle mist of matter slowly rearranges itself into a great network, a kind of three-dimensional lace. Astronomers call it the cosmic web. You can think of it as a web of galaxies or a web of invisible dark matter with galaxies like dewdrops hanging along the strands. In this cosmic web, the bright filaments and thick walls are where matter has gathered and stayed. The dark bubbles in between are where matter has left and not come back. Galaxies live along the strands and at the intersections in clusters and superclusters that trace out this hidden architecture. The voids are the vast, balloon-like spaces in between, the places where the web thins out to almost nothing. A typical cosmic void might be 10 or 50 or 100 million light years across, with only 10 to 20% of the average cosmic density. The Buddhist void is larger and deeper than most, but it is not a mistake. It is simply what happens when an underdense region has had a very long time to empty. So when you hear the phrase cosmic web or large-scale structure, remember that the darkness is part of the design. The brightest clusters need the emptiest surroundings. The filaments need the gaps between them. The darkest places in the universe are not accidents or tears in reality. They are the natural outcome of gravity sculpting an almost featureless beginning into a world of crowded strands and almost silent, interwoven voids. And all of it follows from those first faint ripples you met a moment ago stretched across the sky. So now that you've seen the bright web, let me tell you what it would feel like to live in the dark between the strands. Imagine a planet with oceans and clouds, and someone looking up at the sky, but the whole system is tucked away inside a small, lonely galaxy, floating near the center of a vast void like the Buddhist void. From the ground, day would feel familiar, a sun in the sky, seasons, weather, the slow rhythm of time passing. Gravity under your feet would be steady. If you dropped a stone, it would fall. Planets would still trace their quiet ellipses. Stars would still circle the center of their modest galaxy. Locally, the mathematics of gravity would work exactly as it does here. But then night would come. Think about your own night sky for a moment. The Milky Way is a hazy river. Constellations, a background so crowded that long exposures reveal millions of stars, and if you know where to look, nearby galaxies like Andromeda hanging as soft clouds. Now erase almost all of that. On this void world, you might walk outside and see only a thin scattering of faint points. No bright Milky Way band, because your galaxy is small and not especially rich in stars. No grand parade of neighboring galaxies, because there are hardly any neighbors at all. Just a dim, uneven smear if you use a telescope and stare for a very long time. The distant walls of the cosmic web reduced to a ghostly glow at the edge of visibility. Here's what we do know. A region like the Buddhist void can stretch hundreds of millions of light years across and still contain only a few dozen galaxies. If your entire visible universe lived inside that bubble, the numbers you measured would tell a very different story about reality.
You would weigh your galaxy and find almost nothing else to compare it to.
You would map the sky and see no great clusters, no dense chains of galaxies marching across space. The gentle tug from other islands of matter would be weaker, more distant, almost an afterthought in your equations. And that's where the psychology quietly slips in. If you grew up under that thin, lonely sky, you might conclude that galaxies are rare accidents, that the universe is mostly empty, that life, if it exists at all, probably happened once. It's so simple, it's almost funny. The same cosmos, the same large-scale structure, but from your small, quiet vantage point, the whole world of possibilities would collapse into a story of near-total isolation. We honestly don't know for certain what that would do to a civilization's imagination. Would their philosophies lean toward resignation or toward a fierce, careful hope? And if you were born there, staring into a darkness that seems to go on forever, would you ever even suspect that most of the universe lies far beyond your visible horizon? So let me tell you, before we go any deeper into those vast, silent regions between the galaxies, I want to pause the cosmic story for a moment and look down, not out into the void, but back toward Earth. Imagine that everything about our planet is the same. The oceans, the mountains, the slow drift of seasons, the way someone looks up at the sky at the end of a long day. But when night falls, the world does not light up with stars. There's no Milky Way, no bright band of light stretching from horizon to horizon, no soft dust of countless suns. Overhead, there's only a deep, uniform darkness with a few lonely points of light scattered here and there. A dozen, maybe, on a good night. Think about what that would do to the beginning of human curiosity. Navigation would have to cling to the ground. You would follow rivers, coastlines, mountain ridges. You might still notice that one particular star rises over a certain hill in a certain season, but there would be no grand map in the sky, no careful web of constellations to memorize. Stories would change. Instead of great animals traced in starlight, you would have just a handful of piercing dots to work with. Each one might become almost unbearably important. This one is the ancestor, that one is the eye of a god. Another is a warning that winter is coming. So few lights that every one of them would carry a weight of meaning. Early science would change too. With no river of stars overhead, no nearby galaxies as faint smudges, the idea of a vast universe full of other systems would be harder to reach. The sky would look finished, complete. You might build careful numbers and careful measurements, but the scale of your world would feel smaller. Here's what we do know from our own experience. The Milky Way itself acts like a quiet hint that there is more out there than you can see. Take that away, and the hint disappears. It becomes almost reasonable to think that the universe ends just past the air you breathe, that the few visible stars are rare, isolated islands in an endless, featureless night. In a place like that, an entire philosophy could grow around an illusion of cosmic loneliness, a careful, serious mathematics of emptiness, a story in which life is a unique accident, because you never see anything that suggests otherwise. And all of it would feel so obvious, so simple, it's almost funny. That's where the connection to real cosmic voids becomes unsettling. There are regions in the actual universe where the sky would look eerily like this. A few thin threads of galaxies, and then almost nothing at all. In a moment, we'll leave this thought experiment behind and look at what astronomers really see when they map the large-scale structure of the cosmos, and what it means to stumble across a space so underpopulated that it almost erases your sense of what universe even means. So when astronomers go looking for real emptiness, they do something very simple that leads to something very strange. They count, not sheep this time, but galaxies. Let me tell you how that works. You point a telescope at a patch of sky and you stay there patiently, hour after hour, sometimes night after night, gathering the faintest pinpricks of light that have been traveling through space for hundreds of millions, even billions of years. Each little blur is a galaxy, an island of stars. You measure exactly where it sits on the sky, like putting a tiny pin in a map. But a flat map is not enough. You also want to know how far away it is. So you spread the light out into a spectrum and see how much it has been stretched or redshifted by the expansion of the universe. The more it is shifted toward the red, the farther it is. With just those two pieces of information, position and redshift, you can turn the sky into a three-dimensional picture. Do this not for 10 galaxies, not for 100, but for 1,000,000, and you begin to see something. This is what projects like the Sloan Digital Sky Survey did, night after night, a robotic telescope sweeping the sky, quietly building up a catalogue of galaxies and their distances, like someone filling in a cosmic spreadsheet. When you finally plot all those points in space, you might expect a random sprinkle, like sugar scattered on a table. That is not what you see. Instead, patterns emerge, long, delicate filaments where galaxies line up in chains, dense knots where several filaments meet and clusters form, bright knots of light packed together. And between them, separated by tens or hundreds of millions of light years, are the gaps. Dark, yawning regions where the pins on your map almost stop. Those are the voids. Here's what we do know about them. A void is not a perfect bubble of absolute nothing. Some of it is going to be definition. Astronomers draw a boundary wherever the number of galaxies drops below a certain fraction of the cosmic average. If the universe on average has one galaxy in a box of a given size, a void might have 1/10 of that or even less. It is a statistical emptiness, an underpopulated neighborhood. But when you see the maps, that explanation feels almost too modest. The bright structures form a kind of lace or a spider web, and the voids swell up between them like enormous invisible balloons. The whole universe, on its largest scales, starts to look like foam in a sink, with the galaxies and clusters making up only the thin, fragile walls. Think about that for a moment. The world you know, every star you have ever seen would live on one of those thin walls. Almost everything else would be bubble. In a moment we'll step inside one of those bubbles and ask what it would feel like to live there, in a place so empty that even time's story seems to slow to a whisper. So let's do that. Let's pick one bubble and step inside. Astronomers have given this one a name, the Buddhist void. If you could zoom out far enough to see a map of nearby galaxies, you'd see a bright, tangled web of filaments and clusters, almost like veins of light running through the dark. And then in one direction you'd notice something else. A vast, nearly perfect sphere where the web just thins away. The Buddhist void is about 330 million light years across. Think about that for a moment. Light, which can circle the Earth 7 times in a single second, would need hundreds of millions of years to cross from one side of this bubble to the other. In all that volume, in all that time, you would expect, in a more uniform universe, tens of thousands of galaxies, swirling islands of stars, scattered more or less evenly. But here's what we do know, that is not what we see. When astronomers first surveyed this region, they found only a tiny fraction of the galaxies that the numbers predicted. Not a gentle dip. An extreme underdensity, a cosmic desert. Even today, with better telescopes and patient catalogues, the count remains painfully low. For every galaxy you find inside, there are many, many that simply are not there. The few that do exist become almost like lonely outposts. Imagine one small spiral galaxy, something roughly like the Milky Way, but exiled far from the main highways of the cosmic web. Its nearest large neighbor might be tens or even hundreds of millions of light years away. No rich cluster nearby. No busy filament of companions. Just an occasional faint smudge on the deepest image, so distant that even its light feels tentative. If someone lived on a planet in that spiral, their night sky would still have stars. Locally, their galaxy would feel full and bright, but when they built telescopes and tried to map the wider world, they might find almost nothing. A few scattered galaxies, and then a silence that stretches on and on. It is so simple, it's almost funny you do the same experiment in most directions and see a crowded universe. You point into the Buddhist void and the universe forgets to answer. How does a hole like this appear in a cosmos that began so smooth? The current idea is that a very long time ago in the early universe there were tiny regions that were just a little less dense than average. Gravity pulled matter away towards slightly richer patches, and cosmic expansion helped the emptiness grow. Over billions of years, a small dip deepened into a great hollow, with matter drifting out, walls thickening, and the center becoming ever more vacant. And all of it leads to a final, quiet picture. A small spiral galaxy drifting through a darkness so deep that in every direction other galaxies are only faint, patient smudges. No roaring accretion disks, no violent jets, just the slow expansion of space and the thin hiss of background radiation. In a moment, we'll ask what it would actually feel like to stand there and look up, and whether you'd even trust your own sense of being in a universe at all. If you were dropped into that darkness, you might expect the most dangerous thing in the universe to look the darkest. But let me tell you, the places that can kill you most quickly are often the ones that shine the brightest. Think about a black hole that is actually feeding, not a quiet, lonely one, but one sitting in the middle of a galaxy with gas and dust slowly drifting toward it. As that matter falls in, it doesn't just disappear. It piles up into an accretion disk, a bright, whirling ring of material spiraling down the drain. Friction and gravity squeeze it, heat it, drive its temperature to millions of degrees. At those temperatures, atoms are stripped apart, electrons and nuclei rush around in a hot plasma, and the disk blazes. X-rays, ultraviolet light, even visible light pour out. Some of it is going to be channeled into narrow focused jets, thin beams of particles and radiation that can stretch for thousands of light years out of the galaxy. A black hole doing this is not a dark thing, it is more like a lighthouse. Here's what we do know. When a supermassive black hole at the center of a galaxy is really active, we call it a quasar. And a quasar can outshine every single star in its host galaxy combined. One tiny region, smaller than the orbit of our planets, can be brighter than hundreds of billions of suns. It is so simple, it is almost funny. The object we named black can, in practice, become one of the most luminous things in the universe. Now put that next to a cosmic void. Inside a deep void, there's almost nothing to fall. The gas is thin, the galaxies are few and far between, so there's no crowded disk of matter rubbing against itself, no shocks, no roaring jets. Most of space there just sits, quiet, dark. You could wait for a very long time and almost nothing would happen. No star would suddenly flare just above your head. No brilliant quasar would dominate the sky. The background glow of the universe would wash over you, faint and even like the memory of light rather than light itself, in a strange way. This is the opposite of drama. It is the absence of a story. In terms of personal danger, a black hole wins easily. Get too close, and you're stretched, heated, shredded. But in terms of mood, of what it does to your sense of being in a living cosmos, the void has its own quieter terror. It suggests a universe that has moved on. The darkest place is not where things are torn apart. It is where there is almost no one and almost nothing, and all of it may stay that way. In a moment, we'll slow down even more and imagine what that does to your sense of time and to the simple idea that you belong to a larger, visible world at all. So let me tell you what makes that even stranger. The universe does not just leave these empty places alone. It helps them grow. Gravity, which you usually imagine as this universal pull that drags everything together, is quietly biased. It pulls harder where there's more stuff. If you have a region with many galaxies, much gas, a thick knot of invisible dark matter, and right next to it a region that is just a little thinner than average gravity, does not treat them equally. The rich region pulls more strongly, the thin region loses. Think about a landscape of hills and shallow valleys, but made of density instead of rock. Where the hills are high, matter rolls inward. Where the land is just slightly low, matter slowly drains away, trickling toward the nearby ridges. On cosmic scales. That is where voids begin, not as perfect holes, but as places that were only a little underdense a very long time ago. Here's what we do know: over billions of years matter flows. Tiny differences in the early universe, fractions of a percent, let some regions become filaments and clusters, while others are gently emptied out. The galaxies that once wandered through those slightly thin patches are tugged very slowly toward the denser walls around them. The voids are not carved, they are left behind inside a mature void. This feels almost like an outward push, but nothing is really pushing. A galaxy sitting off-center in a large empty region simply feels more gravity in the direction of the surrounding web, and less from the side where there is almost nothing. So its path bends over enough time, it drifts away from the center toward the brighter borders. In the middle, the emptiness deepens. It is so simple, it is almost funny. Gravity. The thing we blame for everything falling in is the same thing that makes empty places fall out of the story. Denser regions attract more and more material. Under denser regions surrender what little they have. Richness attracts more richness. Emptiness is quietly abandoned. Now add the expansion of the universe itself. Space is stretching everywhere, all at once. In dense regions, gravity fights back, binding galaxies into clusters and filaments that resist this pull. But in the voids, there's almost nothing to resist. As the universe expands, these already thin regions stretch more easily. Their matter spreads even farther apart, and the contrast sharpens. Walls grow brighter, voids grow darker. On the grandest scales, you live in a cosmos where the bright structures are like a fragile lacework, and the dark spaces between them are swelling seas. And all of it follows that same quiet rule: where there is something, more tends to gather; where there is almost nothing, time only makes the nothing larger. In a moment, we'll step inside one of these growing deserts and ask what your own experience of sky and time would become if the universe had very gently left you there. Before we walk all the way into that desert, it helps to pause, to turn around just for a moment and look at the whole thing from a distance. Not as a map with numbers and coordinates, but as something softer, almost like a painting someone has been working on for a very long time. Think about the way a painting works. Your eye goes first to the bright strokes, a face, a tree, a distant mountain. But those shapes only feel solid because they're surrounded by something quieter. The sky behind the branches, the blank wall around a window, the calm water under a boat. That background is not an afterthought in art. It even has a name: negative space. Negative space is the part you don't look at directly, but you would miss it instantly if it were gone. It's the gap between two hands that makes a gesture feel tense. It's the wide, pale sky that makes a single bird seem lonely. It's the silence around a figure that tells you without any words that they are alone. Music does the same thing with time instead of canvas. Notes by themselves are just little events, tiny disturbances in the air. What turns them into melody is the spacing, the tiny rests, the held breath between one sound and the next. Take those away, and the music collapses into noise. Leave them in, and suddenly there's rhythm and meaning and room for you. Let me tell you, the universe seems to have learned that same quiet lesson. The bright filaments and clusters, the places where galaxies crowd together, are like the painted figures and the notes. The cosmic voids are the negative space. Their almost total emptiness makes the web of matter stand out more sharply, the way a single careful line of ink glows against a blank page. Here's what we do know: your mind is drawn almost automatically to the structure, to the glowing clusters, the spirals of stars, the places where something is obviously happening. We build stories there, we point telescopes there. We give those regions names and catalogue numbers and long, careful descriptions. But the spaces in between quietly set the stage. They decide how large the walls of galaxies can grow, how far a filament can stretch before it thins into nothing. They give the whole cosmos its texture, light against dark, fullness against absence. In that sense, the Buddhist void is not just a missing piece. It is part of the frame that lets the rest of the picture make sense. And in your own experience, the same pattern is there. You remember the crowded days, the exam, the wedding, the strange phone call in the middle of the night. But the long, uneventful afternoons around them are what make those moments stand out at all. It's so simple, it's almost funny, and yet we overlook it again and again. Some of it is going to blur, and that's all right. You do not need to hold the exact sizes of voids in your head, or the detailed mathematics of how they grow. What matters is the feeling that emptiness and fullness are partners, not enemies. That the dark and the light are shaping each other patiently across impossible distances. In a moment, we'll let the frame fall away again and return to the desert itself. Not as an abstract idea this time, but as a sky you could stand under and a silence you could actually hear. So let me tell you what happens when you finally walk out into that desert of galaxies. You're not in ordinary space anymore. You're inside a void, a place where the universe has quietly under-delivered on its promise to fill itself with stars. Here's what we do know. On very large scales, gravity is a game of averages. In our own cosmic neighborhood, you are surrounded by clusters, filaments, and walls of matter, all tugging on one another, slowing the expansion just a little. In a void, that average pull is weaker. There's simply less someone out there to hold you back. So the space itself does something very simple, and almost funny in how straightforward it is. It expands a little faster, not because a new force has appeared, but because an old one is missing. The same dark energy that pushes everything apart is working here too, but with fewer galaxies and less mass to resist it. The local expansion rate in a void runs slightly ahead of denser regions. If you could watch this from above, with a godlike sense of time, you would see the difference. In a cluster, galaxies dance around each other, fall inward, collide and merge. In a void, the few lonely galaxies mostly drift apart, riding the general expansion of the universe with almost nothing to anchor them. Think about two galaxies in the Botti's void separated by hundreds of millions of light years. There's no great cluster between them, no thick filament of matter to slow their recession. With each passing billion years, the light they send to each other has farther to go, and less chance of ever arriving before the universe stretches the distance even more. That gentle change in gravity also touches time. General relativity tells us that where gravity is strong, time runs a little slower, and where it is weak, time runs a little faster. So in principle, a clock left deep inside a void would tick ever so slightly ahead of an identical clock left near a massive cluster over the age of the universe. It would win a tiny race it never meant to run. For the galaxies themselves, this means a different kind of life story. Fewer mergers, fewer collisions, less violent stirring of gas and stars. Void galaxies often look strangely pristine, extended delicate gas disks, faint spiral arms, fewer scars from past encounters. Someone living there might see a sky that is thinner, quieter, with fewer bright intruders. A void, in other words, is not just empty space. It is a distinct physical environment with its own gentle rules, shaped not by what is present but by what is missing. And if the rules are different here now, you might wonder what happens when the whole universe slowly starts to resemble a void. So let me tell you what it would feel like if that future arrived early. Imagine you were born in one of those places where the universe already looks tired. A small, quiet galaxy, floating deep inside a vast cosmic void, so far from the bright filaments that, from our point of view, outline the great web of matter. You grow up on a planet with a star that is perfectly ordinary. Warm days, familiar seasons, clouds that come and go. Nothing in your everyday experience tells you that the wider world is strange. The first hint comes at night. You step outside, you look up, and the sky is thin. A few bright stars, a faint smear that is your own fragile galaxy, stretched like a pale cloud. But the rest is not the busy, glittering dome you and I are used to. It is a dark canvas with only a handful of careful pinpricks. Think about what early astronomy would look like there. You'd have time and curiosity and simple tools. You'd map the motions of the nearby stars, trace the shape of your galaxy, measure its slow turning. After a while you might notice a tiny fuzzy patch or two, one or two neighboring galaxies, dim and far, and then nothing, no great clusters crowding the horizon. No long chains of galaxies receding into the distance. Just a small island of light in an ocean that refuses to answer back. If you tried to build a picture of the cosmos from that, the obvious idea would be that the universe is mostly empty and mostly still. Your numbers would agree, your telescopes would agree. The few galaxies you can see would barely seem to move apart, because there are so few of them to measure against. Here's what we do know. Even in our rich neighborhood, measuring cosmic expansion was hard. It took a century of careful work, standard candles, distant supernovae, and whole catalogues of galaxies. In a void with only a handful of dim beacons, that same task becomes almost impossible. The underlying web is there, but it hides behind a simple lack of examples, which is almost funny in a quiet way. For a very long time, no one in that world would suspect that far beyond their darkness, matter gathers into filaments and walls. The large-scale structure would be an invisible story, so their questions might turn inward instead. Are we alone because the universe is shy, or because it is finished? Is the silence a message, or just the way things are when there was never very much to begin with? Someone would write myths to fill the gaps between the stars. Someone else would insist that the emptiness itself is the myth. And all of it would feel complete, self-contained, like the only possible version of reality. From our busier corner, with a Milky Way full of glowing neighbors, we see a universe that is crowded, expanding, web-like. But that might be just one local story. Out there in the darkest neighborhoods, the same universe is telling itself a slower, lonelier tale. The unsettling part is that as time goes on, our story and theirs start to converge. As those stories converge, something strange happens to our fears as well. You might think the obvious nightmare is the violent one, the place where gravity stretches you like taffy and light itself cannot climb back out. A black hole feels like the villain of the universe. It has teeth, it has a clear beginning, a fall, and a very definite end. But let me tell you, destruction at least gives you a plot. If you fell toward a black hole, your experience would be brief, intense, and in a very direct way meaningful. Every second would matter. The numbers on your clock would race, the light would redden, the tidal forces would grow. There would be a climax in a deep cosmic void. Nothing like that happens. Think about a galaxy placed near the center of the Bootis void. that huge region hundreds of millions of light years across with almost nothing in it. No roaring accretion disks, no bright jets, just a slow, uneventful drift through space so underpopulated that if the Milky Way lived there, we might decide the entire universe contained only us. You do not get torn apart. You do not get a dramatic final scene. You simply orbit and wait and age. Human fear does not only answer to danger, it also answers to silence, to being the only one in the room, to the feeling that no one will ever knock on the door in everyday life. People describe the worst moments not as the most painful, but as the loneliest, the empty house, the phone that never rings, the long hospital night where nothing changes. Cosmic voids are that feeling written across hundreds of millions of light years. Here's what we do know. In those regions, the gaps between the thin threads of galaxies are so wide that a signal moving at the speed of light can take hundreds of millions of years just to cross from one island of stars to another. You could send a message, and not only would you never hear the reply, no one you know and no one they know would be alive to hear it either. The universe is still playing by its usual rules of mathematics and physics there. Gravity works, time flows, but the story it tells is almost perfectly flat. No great collisions, no bright fireworks, just a graph of existence that looks like a long, nearly straight line. And that is where emptiness can feel worse than destruction. A black hole offers you an arc, falling, crossing a point of no return, vanishing. A void offers you almost no story at all. Some of it is going to be waiting. Some of it is going to be repetition, and all of it is going to be very, very quiet. Which image sits more heavily in your mind? A sudden violent end near a black hole, or an eternity spent in a place where nothing answers, nothing changes, and the sky itself seems to have forgotten you were there? Because if you follow the universe far enough into its own future, that second picture starts to look less like a thought experiment and more like a preview. So let me tell you, before we go any farther into that lonely future, I want you to do something strange. Forget the black holes for a moment, forget even the galaxies. Imagine we start to zoom out, not from the Earth, not even from the Milky Way, but from everything you usually picture when you think about the universe. You watch the Milky Way shrink from a bright spiral to a coin, then to a pinprick, then to a speck so small you'd lose it if you blinked. Keep going. The Andromeda galaxy beside it collapses to a point. The whole local group, with its dozens of little companion galaxies, melts into a single bead of light. You're still not nearly far enough away. We keep pulling back until every cluster of galaxies, every supercluster, is just another dot in a faint, three-dimensional haze. And then very slowly a pattern begins to appear. Think about a bath full of soap bubbles, thin, shimmering walls enclosing around empty pockets. On the largest scales we can see, the universe looks a little like that, a kind of cosmic foam, not flat, but a vast three-dimensional web of bright filaments and sheets where galaxies live, wrapped around enormous, mostly dark bubbles. Astronomers call those bubbles voids. Some are 10 million light years across. Some are 100 million. The Bootes void is more than 300 million light years wide. A region where by all rights there should be thousands of galaxies, and yet there are only a few dozen. So simple to describe. It's almost funny, a place that is mostly nothing. Here's what we do know. If you could somehow hold the observable universe in your hands and measure it, most of its volume would be inside those bubbles, not in the bright walls, not in the crowded clusters, in the quiet, underfilled regions in between. The matter, the stars, the planets, the black holes. Almost everything you think of when you hear the word universe is crammed into the thin, glowing filaments. But the space, the actual room available, belongs to the voids. Emptiness, in a very literal sense, takes up more space than fullness. That's where the picture becomes a little unsettling. Because when you zoom out this far, you realize that the luminous structures we celebrate are not the main event. They're the decoration on the surface of a much larger, darker reality. And all of it, every galaxy and every gap, grew from tiny ripples in density a very long time ago. Some of it is going to be familiar cosmic drama, but most of the universe is made of regions where almost nothing happens and almost nothing ever will. The darkest places in the universe, then, are not rare, exotic exceptions. They are the background, the default, the quiet ocean on which every bright island of stars is just barely floating. In the next step, we can stop looking at the whole foam at once and dive into a single bubble to see what it would mean to actually live inside that darkness. So let me tell you, when you zoom in from the whole foamy web of the cosmos and land inside a single bubble, you don't suddenly find something normal and crowded. You just find a quieter kind of strange. The Buddhist void is the dramatic example, the one that makes headlines, but it's not the only one. All across the universe, there are typical voids, if you can even call anything that big, typical. Most of them are only 10 to 100 million light years across. Only. You could line up the entire Milky Way, end to end, dozens of times inside one of these and still have room left over. Think about your experience of distance, a long drive, a flight across the world, light from the sun taking 8 minutes to reach you. Now stretch that to 10 million years of light travel, then to 100 million, and that whole span is mostly nothing. Not absolutely empty, but thin, underfilled. Here's what we do know. If you took a big enough box of the universe at random, you'd expect a certain average number of galaxies in it. In a typical void, you get maybe 10 to 20% of that number. One lonely galaxy here, another one tens of millions of light years away. The gaps between them are so large that from any one of those islands of stars, the others might be barely visible at all. And the emptiness has its own structure. Voids come in a kind of hierarchy, a nesting of absence. Inside a large void, you can find smaller, slightly less empty regions, like bubbles within bubbles. Within those, still smaller hollows. The bright parts of the universe form filaments and sheets, but the dark parts also organize themselves not into objects, but into layers of almost nothing. Someone might imagine this as chaos, as random gaps where matter simply failed to show up. But astronomers treat these places with the same calm bookkeeping they use for galaxies and clusters. They map them, they catalogue them, they assign each void a position, a size, a measured underdensity, and then compare those numbers to the patterns predicted by our cosmological models. If the models say there should be a certain distribution of bubble sizes, and the sky gives us a different answer, that quiet disagreement becomes a clue. It's in a way so simple it's almost funny. To understand the universe, you don't just count what is there. You have to count what is missing. You have to measure the gap. So emptiness is not an afterthought, not a mistake the universe made and then forgot to fix. It is regular, it is measurable, it is built into the architecture from the very beginning, a partner to matter in shaping where galaxies can form and how they move over time. And all of it raises a quieter, more personal question. If these structured deserts of space are the rule rather than the exception, what would it mean for someone like you to actually live in one of them, to look up and see that almost nothing sky? That's where we're going next. To answer that, you don't have to throw yourself into the very middle of a void. You just have to walk to the edge. Think about a galaxy that lives on one of those thin, foamy walls of the cosmic web. On one side, a great emptiness falls away, a volume of space that might stretch tens or even hundreds of millions of light years with almost nothing in it. On the other side, the web thickens into filaments and knots where clusters and superclusters gather. It is a border town between almost nothing and almost crowded. If you stood inside such a galaxy and could somehow see the universe all at once, one half of your sky would be richer. You would trace chains of galaxies, bright islands strung like beads along invisible threads of gravity. The other half would be quieter, with fewer lights, the way a coastline looks when the land just stops and the dark sea begins. Not empty exactly, but trending that way. Here's what we do know. Galaxies in these border regions tend to experience fewer close encounters and mergers than their cousins in the bustling centers of rich clusters. They are still part of the web, still feeling its pull, but they are not packed shoulder to shoulder. Over billions of years, that can mean a different kind of life story, fewer violent collisions, fewer sudden bursts of star formation followed by exhaustion, more time for a slow, steady burn. In a quiet galaxy like that, gas clouds can collapse into stars at a gentler pace. Disks can stay relatively undisturbed. Spiral arms can keep their shape for a very long time. It is not a guarantee of peace. Supernovae still explode, black holes still feed. But the background rhythm is less frantic, and once you start thinking about that, it is hard not to wonder about habitability. If you're trying to build complex life, you might prefer a neighborhood where the big catastrophes are rare, fewer nearby galaxies sweeping past, fewer tidal upheavals, fewer jets of energy blasting through your sky. Someone living on a rocky world in such a place might get hundreds of millions of years as a stretch where nothing very dramatic happens on the galactic scale, which is so simple it is almost funny. The universe, by doing less, might be helping more. Now put that beside the life of a galaxy in a rich cluster. There the sky is crowded. Bright neighbors loom in every direction. Galaxies plunge through hot gas, ram into one another, tear off streams of stars. It is spectacular and exhausting. We honestly don't know for certain which environment is better for life. Some of it is going to be luck, and all of it is tangled up with local details. But let me tell you one last picture. If life exists out there on the edge of a void, someone might walk out under their night sky and see a universe divided, one half thick with galaxies, the other half opening onto a vast dark nothing. And that asymmetry, that feeling of living next to an abyss, is going to matter for what we talk about next. So let's pause there for a moment. You've been standing with someone on the edge of an abyss, looking out at that uneven sky, and it might be a good time to gently gather the pieces of the story we've been slowly building. We began in a familiar place. Your own night sky, a thin sprinkling of stars, a cloudy river of the Milky Way, the quiet feeling that darkness is just the backdrop and the light is what matters. And then we pulled the camera back, step by step, until that soft darkness turned out not to be the deepest darkness at all. Because black holes, for all their reputation, are actually busy. They sit in the bright hearts of galaxies, wrapped in swirling disks of gas, lighting up the universe as matter falls in and heats to impossible temperatures. They flare, they feed, they throw out jets. If you were falling toward one, something would be happening every moment. But between those galaxies and between the clusters that hold them, we found something quieter. We found the cosmic web. Thin filaments of matter, like threads of light, outlining a three-dimensional pattern where gravity has slowly pulled things together over a very long time. And in between the threads there are bubbles. Vast regions where almost nothing gathered at all. Those are the voids, not perfectly empty, but underdense with only a fraction of the usual galaxies and almost no drama. In a typical void, you could travel tens of millions of light years and pass only a handful of islands of stars. Most of the time, nothing collides, nothing lights up, nothing new is born. It just expands to make that less abstract we talked about. The boat is void. A single bubble, roughly 330 million light years across. So empty that if the Milky Way were sitting in its center, our sky would be nearly blank. You might see a few lonely smudges and then nothing. And here's what we do know. Regions like that are not rare exceptions. Most of the volume of the universe lives inside these underpopulated bubbles. The bright web you see in pictures is only the thin frosting on an enormous dark cake. Think about what that does to your sense of fear and wonder. We take comfort in structure, in our galaxy, in our cluster, in the idea that there's always another star just beyond the next patch of night. Black holes are frightening, but they are still part of that structure, still tied into the busy story of matter. A void offers you something else, a kind of endless, almost featureless silence that is so simple, it's almost funny and yet strangely unsettling. If the details are beginning to blur, that's all right. Some of it is going to be like a half-remembered dream anyway. You might even feel your eyes getting heavy. You can let them. The important thing is the feeling, a universe whose bright pattern floats on an ocean of almost nothing. Because from here, we're going to let time run forward. We're going to watch those webs thin, the lights go out and the voids grow. And all of it is heading toward a future where the darkest places we've met so far are only the beginning. So here is the strange twist. The universe does not race toward its darkest future in a blaze of catastrophe. It gets there by doing almost nothing at all. If you let time run far enough forward in your mind, you can watch the simple things fail first. Stars, for example, are not eternal. They are engines burning a limited supply of nuclear fuel, quietly turning hydrogen into heavier elements and light. Given long enough, every star you see will either exhaust that fuel and fade into a cold remnant, or explode once and then leave something dim behind. No new fuel is being delivered. Once it is used, it stays used. Galaxies, taken as a whole, follow the same slow rule. Right now, the Milky Way is still forming new stars from great clouds of gas. But each generation of stars locks some of that gas away forever in white dwarfs, neutron stars, and black holes. The bright blue stars burn fast and vanish. The small red ones burn slowly but not infinitely. Over unimaginable stretches of time, the rate of new star formation drops. Then it dwindles. Then it almost stops. And while all of this quiet spending of fuel is happening, the stage itself is changing under our feet. Here's what we do know. The space between galaxies is not just expanding. It is expanding faster and faster, driven by something we call dark energy. No one is completely sure what dark energy really is. We honestly don't know for certain. We only see its effect. Galaxies that used to slow each other down with gravity are now being pushed apart more strongly as time goes on. Think about what that means if you wait long enough. Light has a finite speed. There's a horizon around you, a limit to how far you can ever see, even in principle. As dark energy drives the expansion to accelerate, more and more distant galaxies slip beyond that horizon. They do not vanish in any dramatic way. They simply recede until their light can never quite reach you. Your local group of galaxies becomes an island. Everything else drifts out of view. That is where the voids we see today start to look like a preview. Right now, the cosmic web has bright filaments and dark gaps like a faint city seen from an airplane at night. In the far future, the gaps grow, the filaments thin. The great underdense regions swell until almost every direction is effectively a void. It is so simple. It is almost funny to make the universe darker. You mostly just wait. Let me tell you, this is not a universe filled with endless fireworks. It is a universe that spends its energy once and then slowly forgets how to shine. The long-term story is a quiet slide into deeper and deeper darkness, where the brightest events are in the past, and each new epoch feels more like an afterglow than a beginning. And all of it is only the middle of the tale we still have to follow. So if the long-term story is a slide into darkness, there's a kind of ending waiting there that is stranger than any black hole. It even has a very gentle name. Physicists call it heat death. Not because the universe bursts into flame, but because in a quiet and technical sense, the drama of temperature is over. The differences are gone. Let me tell you what that means in simple terms. Right now, stars are hot, space is cold, and that contrast is what lets things happen. Heat flows, engines run, chemistry ticks along. You sitting here are powered by a temperature difference between your warm body and the cooler world around you. Useful work is just that, energy moving from a place where it is concentrated to a place where it is thin. Heat, death is the moment unimaginably far in the future, when that game has finished. Energy is still there, but it has been shared out so evenly that there are no big hills and valleys left in the cosmic landscape. No large temperature differences, no bright hot spots and cold dark corners, just a thin, almost uniform bath of low-energy radiation. The universe's last lukewarm whisper. In that state, there's nothing for engines to push against, no way to build a star, no way to light a new flame. Things can jiggle, but they cannot organize. It is a world where, in a very precise sense, no more surprises can happen. The numbers have all been shuffled and reshuffled until every hand looks the same. Here's what we do know about the path to that quiet end. As time stretches on, galaxies drift apart, then slip beyond one another's horizons. Stars burn out, matter itself becomes sparse, thinned and scattered. Planets erode into dust. Dust is torn into individual atoms, and even those atoms, given enough time, may decay. Structures that once seemed eternal dissolve. Think about a cosmic void like the Baltis void, already hundreds of millions of light years wide and nearly empty. Now imagine that kind of emptiness, not as a bubble between filaments, but as the baseline state of everything. No web, no filaments, just a featureless, nearly empty expanse stretched out beyond easy comprehension, where almost nothing happens and almost nothing can. It is tempting to say, well, the universe was nearly uniform at the beginning too. A very long time ago, just after the Big Bang, space was also smooth. But then it was hot and dense, bursting with potential, tiny fluctuations waiting to grow into galaxies and stars. Heat, death is the mirror image of that beginning, cold, dilute, smoothed out, not by promise but by exhaustion. And somewhere in that far future, even black holes lose their role as monsters. They slowly leak away their mass, radiating faintly until they too fade into the background glow. The darkest objects we know become, in the end, just a small contribution to a wider, deeper darkness. We honestly don't know for certain how that final darkness will feel from the inside, or whether anyone will be there to feel it. But there's one more twist in this story of emptiness, one more way the universe can hide its last traces of light, and that is where we have to go next. If black holes were the monsters of this story, you might expect them to be the final ones left standing. But here's what we do know, even the monsters fade. A long time ago, someone might have imagined a black hole as a perfect, one-way trap for light, a place where nothing ever comes back out. In our modern picture. That isn't quite true. There is a faint leak. And that leak has a name near the event horizon. The very edge of a black hole, quantum physics quietly refuses to stay empty. Pairs of tiny particle-antiparticle flickers appear and vanish, like numbers popping up and cancelling on a page of mathematics. Most of the time it's a brief, forgettable event, but every now and then something different happens. One of the pair falls in, the other escapes. To an observer far away, that escaping piece looks like radiation, a soft glow of energy slowly leaving the black hole. We call it Hawking radiation. It is so weak that for any black hole you can reasonably imagine today, it's almost comically unimportant. So simple. It's almost funny. The bigger the black hole, the colder and dimmer this glow becomes. But give it time, unimaginable time, because every bit of Hawking radiation carries away energy, and energy is mass. So the black hole shrinks very slowly at first, then faster as it gets smaller and hotter. A stellar mass black hole might take something like 10 with 67 zeros after it years to evaporate. The giants at galactic centers with millions or billions of solar masses stretch that number out to something even more absurd. Think about a span of time so long that the current age of the universe is just the tiniest scratch at the beginning. Yet even on those scales, the story has an ending in the far future. After galaxies have dimmed and stars have gone out, the last black holes will finish their long, slow evaporation. There will be no more event horizons, no more compact engines of gravity. Only a thin bath of low-energy radiation stretching across a universe that has already expanded beyond easy comprehension. And this is where the contrast becomes uncomfortable. Black holes have lifetimes. Emptiness does not. Once the universe has thinned out so much that matter can no longer easily clump, once expansion has pushed every remaining particle away from every other, there's nothing left to restart the old drama. No new stars, no new galaxies, no new black holes. What remains is a world of almost perfect uniformity, where every region of space looks nearly the same as every other, and all of it is cold, dark, and quiet. The places where black holes once sat are still there, of course. But now they are simply regions of space like any other, marked only by the absence of anything interesting happening. In that ultimate long run, the most terrifying feature of the cosmos is not being torn apart by gravity. It is being left in a universe where gravity has nothing much left to say, and where emptiness once begun simply goes on. So let's do something a little strange for a moment, pause that endless thinning future, and instead of following galaxies and numbers out into the dark, turn the camera around and look quietly back at yourself. What does it feel like in your own chest to imagine a universe that does not end with a final blaze of drama, but with a long, almost polite fading away? There was a time when the night sky was the opposite of empty. Not in terms of physics, but in terms of story. You would have stood under those same stars a very long time ago and seen not random points of light, but hunters and scorpions, dragons and bears, gods walking slowly across the heavens. Lines were drawn between bright stars. Shapes were traced and whole lives were mapped into the sky. Think about what that really is. Someone takes a handful of bright dots, connects them, and suddenly there's a hero, a warning, a calendar, a promise that the seasons will return. It is so simple, it is almost funny. 3 stars in a row become a belt. A crooked curve becomes a fish. But that impulse to fill the darkness with meaning is as real a force in our world as gravity. And here we are, with better telescopes and better mathematics, discovering that on the largest scales the universe is not a crowded ceiling of stories. It is a web of filaments and clusters, separated by enormous voids where almost nothing happens. Here's what we do know. Most of cosmic space is not like the bright band of the Milky Way you see on a clear night. It is more like the Bootis void, hundreds of millions of light years across, with so few galaxies that if you lived in the middle, you might believe you were alone. That idea pushes against the old stories. Instead of a cosmos packed with watching eyes and deliberate patterns, we meet a universe that is mostly indifferent, mostly empty, slowly heading toward a heat death in which even the last stars go out. The constellations we drew begin to look less like messages and more like our own handwriting on a very large, very blank page. Some of it is going to be unsettling. An empty universe can feel like a personal rejection, as if the world itself had stepped back from you. But emptiness can also be strangely freeing. If almost all of space is dark, then the small pockets of light and life, the brief intervals where chemistry wakes up and asks questions, become all the more precious, more remarkable than fire, more remarkable than language. Even, let me tell you, we honestly don't know for certain why the absence of things can feel so heavy. That's where this turns inward again. Our fear of cosmic emptiness might be a quiet recognition of how much we care about connection, about not being the only point of light in the room. In a moment we will go back to concrete images, to real voids and real galaxies. But for now, just notice that the chill you feel when you imagine that final silent universe is also a measure of how deeply you value the little cluster of warmth you inhabit right now. So let me tell you what happens if we actually keep going with that feeling. Stay where you are for a moment in your familiar world, with the Milky Way stretched like a soft band of light overhead. Then, very slowly, let time begin to run faster, millions of years per heartbeat. Constellations that seemed eternal start to drift. Orion's belt loosens, the Big Dipper warps and tilts until it is simply 7 unrelated stars. Think about that. The pictures you grew up with in the sky were never really there. They were an accident of perspective of where you happened to be and when. Keep turning the dial. Now you're tens of billions of years in the future, standing on Earth or on some quiet successor planet that remembers Earth only as a story. The sun has changed, perhaps the planet is different, but the sky is still there for a while. Galaxies that once appeared as faint smudges in a telescope grow dimmer, then vanish altogether, not because they burned out, but because space has stretched so much that their light can never reach you again. One by one, the great cities of the cosmos step over the horizon of the observable universe. Their last photons arrive like the final letters from a distant friend, delayed, redder, weaker, until the mailbox stays empty forever. Here's what we do know. As expansion continues and accelerates, almost everything outside our small neighborhood is carried away faster than light can bridge the gap. Eventually, only the local group remains, the Milky Way, Andromeda, and a few dozen smaller galaxies huddled together in an ever larger darkness. Wait a little longer. Those remaining islands of stars begin to merge very slowly over unimaginable spans. The Milky Way and Andromeda collide and settle into a single swollen galaxy, sometimes called Milkdromeda, filling a huge patch of the sky with a hazy, intricate glow. Beautiful? Yes. But also strangely lonely. Beyond that bright whirl of stars, there's almost nothing. From the surface of that far future world, the universe would look small again. A single enormous galaxy overhead, perhaps a few faint companions, and then a blackness so deep that it would be tempting to declare it empty. The idea of other galaxies, of a vast web of clusters and voids, would no longer be obvious. It would be an act of imagination. Future astronomers, working with careful measurements and quiet patience, might still piece together clues. Relic radiation, odd motions of distant stars. Some of it is going to be just barely enough to whisper that there was once a larger story. But we honestly don't know for certain how much they will be able to reconstruct. And all of it raises a quiet question. What does it feel like to live in a universe that has hidden almost all of its past? to stand under a sky that has forgotten to admit how big it really is. In the next part, we are going to visit a place that gives us a preview of that future darkness, concentrated into a single enormous absence, and see what happens when you put a galaxy there and ask it to look around. If the Buddhist void is one enormous missing piece, then the far future universe is what happens when the missing pieces win. Let me tell you what that looks like if you zoom the clock forward, not just millions, but trillions of years. Right now, when you see a map of the cosmos, you see that delicate web, bright filaments of galaxies, thick clusters where many threads meet, and in between, those great hollow bubbles we call voids. The emptiness separates the structure, but the structure still spans the emptiness. Light can still cross. Signals can still, in principle, find their way from one side of the web to another, if you give them time. In an accelerating universe, that balance slowly breaks. As expansion speeds up, every little knot of gravity that is strong enough to hold itself together becomes, in effect, an island. Your local group of galaxies, for example, does not get torn apart, the Milky Way. Andromeda, their satellite galaxies, they remain in a single bound family. But beyond the shores of that family, the ocean of space stretches faster and faster, carrying everything else away. Think about standing on a beach where the tide never stops going out, and the waterline is moving faster every moment. At first, distant ships just look farther away. After a while, no matter how bright their lamps, their light never quite reaches you. Not because the lamps went out, but because the space between you and them is growing too quickly. That is what happens to the regions between these island universes. Today's voids, even the Buddhist void, with its 300 million light-year span, are like wide cold valleys between mountain ranges. In the deep future, the valleys swell until the ranges lose sight of one another altogether. The gaps are not just large, they become unreachable in principle. You could shine a beacon forever, and its light would never arrive. Here's what we do know from the mathematics of expansion. Beyond a certain distance, space itself carries things away faster than light can close the gap. No rocket helps, no clever technology solves it. Communication and travel across those growing deserts of nothing become not just impractical but impossible. Inside each island, there's still a sky. Stars still rise and set. Someone a very long time from now might still build telescopes, still write down numbers, still argue about the age of their world. But when they look outward, they will see only their own island, floating in what appears to be an infinite, featureless dark, tiny oases of matter and light, each one wrapped in an ocean of almost perfect nothing, each one effectively unaware that others ever existed at all. And that's where the title of this story bends into focus. The darkest place in the universe is not one special spot hidden somewhere in a map. It is this growing condition, this spreading separation, the expanding black between the last surviving islands of matter. In the next part, we'll follow that idea all the way to its quiet end and ask what it means for a universe when even the islands themselves begin to fade. So let me tell you where we are before we walk any further into that quiet end. We began with places like the Buddhist void, these enormous bubbles in the cosmic web, hundreds of millions of light years across, where almost nothing lives. A few lonely galaxies, a lot of darkness at first. They can feel like rare curiosities, strange exceptions in an otherwise busy universe. But slowly we turned the camera out, we let the scale grow. And you saw that those local voids are not accidents. They are the natural shape of expansion, the empty rooms left behind as matter flows into filaments and clusters. The more the universe stretches, the more those empty rooms swell. Here's what we do know in the very far future. That pattern only deepens. Galaxies drift apart, then race apart, until each one is surrounded by a private region of darkness, a personal Buddhist void that keeps getting larger. The cosmic web thins, the gaps win, and in the middle of all of this we place black holes, dramatic theatrical objects, disks of white-hot gas swirling in, beams of radiation shooting out, gravity so strong that light itself has to negotiate. For a while they are some of the brightest things in the universe, which is almost funny given their reputation. But they are not permanent. Even the heaviest black holes slowly leak away through processes we can write down with numbers. Give them enough time and they fade. The voids that hold them, though, do not fade. The emptiness between galaxies is patient, and it is winning by simply waiting. Think about what that means for stories. A very long time ago, someone looked up and saw a sky crowded with stars, a river of light, wandering planets, faint smudges of other galaxies. There was material for myths everywhere. You could connect the dots in almost any direction and find a shape. In the deep future, an observer in some surviving galaxy may look up and see only their own stars, and nothing beyond. No filaments, no neighboring clusters, no hint that there was ever a wider structure at all. The history of the world will be small, because the visible world will be small. That is where your moment becomes strangely special. You live at a time when the cosmic web is still on display, when telescopes can trace both the bright strands of galaxies and the dark hollows between them. You can place yourself in a map that stretches for billions of light years. Pattern, interrupt, pull the camera all the way back down. Right now your experience is not of a cold void or a dying black hole. It is of a room or a bed or a familiar street. It is of warmth on your skin, of someone's voice, of light that reaches your eyes in less than a heartbeat. Whatever the universe is doing on its longest scales, your own world is dense with connection. Some of it is going to fade far away over unimaginable spans of time. But tonight you are firmly inside a bright local story, and all of it is available to you in this tiny window long before the great emptiness finishes its slow work. In the next section, we'll let that future run forward again and watch what happens as even the last bright structures begin to unravel. If you zoom out far enough, something strange happens. The bright local story you live inside begins to look less like the rule and more like a tiny exception, almost a footnote. We usually talk about emptiness as if it were a failure, a hole in the wall, a gap in the record, a place where there should have been structure, or light, or meaning, and for some reason the universe forgot to put it there. Think about how we use the word in everyday life: an empty room, an empty page, an empty day. Always missing something. But let me tell you, in cosmology, the dark gaps are not mistakes. They are what happens when you let the rules run. Gravity pulls, expansion stretches, tiny ripples from a very long time ago get amplified. Where there was a little more matter, more gathers. Where there was a little less, even more leaks away. Over billions of years, that gentle bias turns into a pattern, filaments, clusters, and in between them great underdense basins of almost nothing. Here's what we do know. If you could draw a box around a huge chunk of the universe, hundreds of millions of light years across, and then ask, what is this box mostly made of? The answer would not be stars, it would not be galaxies. It would be space, thin, cold, almost perfectly empty space, closer to the Bootes void than to the Milky Way. The average state of the cosmos is not a city of light. It is a dark countryside with rare towns, separated by enormous stretches of night. Your intuition fights that, because your intuition was trained in a very different neighborhood. You live pressed up against rock and air and water. You wake up on a dense planet, warmed by a nearby star, wrapped in a world where every direction you look, something is happening. Someone is moving. Numbers in your bank account change, messages arrive, The phone on your nightstand glows. Your whole experience whispers that fullness is normal and emptiness is the exception. Out there, the roles are reversed. The crowded places, the rich clusters where thousands of galaxies huddle together, are the exceptions. They are like rare oases in an enormous desert. The desert is the rule. And that desert is not broken. It is the honest outcome of simple laws doing what they do patiently without anyone steering them. So simple, it is almost funny. Where there is more, you get more. Where there is less, you lose even that. So when you imagine the darkest places in the universe, you can think of them as frightening. Endless distances, almost no light, almost no gravity, almost no story left to tell. But you can also see them as honest. They show you what the universe mostly is when you zoom out far enough and stop insisting that your warm local pocket must be the standard. In the next section, we will follow that honesty even further into a future where the rare bright islands thin out and the cosmic desert finally takes over almost everything. If you stay with that image for a moment, the bright islands fading, the desert taking over, you might notice something happening inside your own mind. There can be a kind of quiet tightening, as if the space behind your ribs has suddenly become larger and emptier than you expected. Imagining a vast cosmic void often does that. You picture hundreds of millions of light years with almost nothing in them, and some deep animal part of you whispers that this is wrong, that you are too small for a world this wide. There's no crowd here, no comforting background noise of stars, just distance. Think about what that implies. No nearby galaxies to fall toward, no bright Milky Way band across your sky. No sense that life is busily happening somewhere just out of sight, in a place like the Bootes void. If you put the Milky Way in the center, astronomers have said, you might look out and genuinely wonder whether anyone else exists at all. That is not the noisy terror of being torn apart. It is the softer, slower terror of being left alone. You feel in that picture how fragile structure really is, how thin the filaments of galaxies are compared to the oceans of nothing between them, how easily, given enough time, even those filaments can drain away into the background. The numbers here are so large that they stop feeling like mathematics and start feeling like weather in the soul. But let me tell you about another reaction someone can have to the same idea. For some people, the emptiness is not a threat, it is a release. If the universe is this vast, this indifferent, then all the small performances of your day, the little mistakes, the awkward conversations, the late emails, shrink down until they are almost funny. Against a backdrop of a 330 million light-year void, the pressure to be important eases. Here's what we do know, both of these responses are reasonable. You can feel the chill of isolation and at the same time a kind of deep calm that comes from realizing you were never being judged by the cosmos in the first place. You can hold dread in one hand and gratitude in the other. Gratitude. That in a universe where most regions really are dark and empty, you happen to occupy a tiny pocket where stars formed, planets cooled, and consciousness had a chance to look around. If you notice your own reaction shifting as we talk, tightness or ease or both, you do not need to argue with it. You can let the thoughts of voids and black holes drift past like slow clouds, changing shape on their own, while you simply watch. No need to grip them, no need to push them away. Just notice that your mind, given a little space, will quietly rearrange itself. Because in a moment we are going to return from pure emptiness to something more concrete. We will take that feeling you now have about the dark between galaxies, and we will compare it one more time with the fate of someone who falls into a black hole instead. And there, in the contrast between drifting forever in a near-perfect void and plunging into a place where space-time itself is torn, something important about the universe and about you will come into focus. So let me tell you two stories. In one you fall, in the other you drift. Same universe, same laws of physics, but the feelings they produce could not be more different. Think about the first journey, the one people usually imagine when they hear the word cosmic horror. You're approaching a black hole, maybe one with an accretion disk, a bright whirl of gas and dust spiraling in. As you get closer, gravity does something very simple and very unforgiving. It pulls more strongly on your feet than on your head. Forces, the same basic idea that moves the oceans on Earth, begin to stretch you. At first it is gentle, a tug. Then as you cross the invisible boundary called the event horizon, it is not gentle anymore. Time itself behaves strangely. To someone watching from far away, you appear to slow down, to freeze, as the light from you has to climb out of a deeper and deeper gravitational well. To you, though, everything feels normal, just faster, brighter, more compressed. Radiation from the accretion disk blazes around you. Space is not quiet here. It is one of the brightest places in the universe, so energetic that matter itself is being torn apart and heated to extremes. Your story has a clear structure, approach, cross the horizon, fall toward the singularity. There's a beginning, a middle, and a very definite end. Now take the second journey. You are headed toward the center of a large cosmic void, something like the Botis void, hundreds of millions of light years across. Here's what we do know. At first the sky looks almost normal. The Milky Way arches overhead. Nearby galaxies still form a gentle spray of light. But as you travel slowly over millions of years, the pattern changes. The bright band of the Milky Way fades as you leave its neighborhoods behind. The scattered galaxies around you grow thinner, constellations unravel, not in a single dramatic moment, but in a way so gradual that you might not notice from one lifetime to the next. There's no event horizon here, no sudden wall in space-time. The local gravity actually gets weaker because there's less matter around to pull on you. Nothing tears you apart, nothing flares, the background radiation cools, the sky becomes emptier, the silence stretches. The terror, if you feel any, lives in a slow realization. You're gliding into a region where the universe has very little left to say. In the black hole story, everything happens. In the void story, almost nothing does. One is a brief, violent chapter. The other is an endless paragraph of ellipses. For a mind like yours that grew up on change and story and connection, some of it is going to be more unsettling than it sounds. Because in the void there is no clear final page. Just more of the same, almost nothing. A place where even time's plot seems to trail off. And all of it raises a quiet question. If the universe can forget to put anything in such a vast region of space, what does that say about its ending a very long time from now? If the universe can forget to put anything in a place as large as the Botis void, it can also forget to carry a message across it. Think about what that means for communication, not in the everyday sense of phone calls and fiber optic cables, but in the slow language of light itself. When astronomers talk about voids tens or hundreds of millions of light years across, they are also talking about the time it takes for even a perfect signal to cross them. A radio wave leaves one lonely galaxy on one side of a void, and it will spend tens of millions of years just getting to the sparse filaments at the edge. Hundreds of millions of years to reach a cluster beyond. You could send a greeting today, and by the time it arrived, the world that sent it might no longer exist in any recognizable way. And that is, if space were merely big. But here's what we do know. Space is not just big, it is changing. The fabric between galaxies is stretching, slowly, gently, relentlessly. A very long time ago, everything was closer together. Now the distant clusters are not just sitting there waiting. They are receding on small scales. Gravity holds things together. Your body, the Earth, the Milky Way, on the scale of superclusters and the dark lanes between them, expansion wins. There comes a distance where the space in between is swelling so quickly that effectively it carries those regions away faster than light can make up the difference. Not because anything is breaking the rules, but because the track itself is lengthening under the runner's feet beyond that shifting boundary, sometimes called a cosmic horizon. A signal you send now will never arrive. Not in 10 billion years, not ever. Communication does not just become difficult, it becomes meaningless. Let me tell you why that matters for the search for other minds. You can imagine someone on a planet around a distant star building their own telescopes, wondering if they are alone. They might fill their sky with radio messages, mathematical patterns, careful sequences of numbers. But if they live far enough away, on the other side of expanding voids, their entire civilization could rise, discover mathematics, build a brief world of science and stories, and fall back into silence, and no trace of that pattern would ever touch us. We honestly don't know for certain how many such islands there are. That's where the unease comes in. The universe, through its geometry and its expansion, imposes hard limits on connection that no technology can outsmart. Some of it is going to be reachable, and all of it beyond a certain line is not. So our messages, our radio waves and wandering probes, leave the thinly populated lanes of our local cosmic web and move outward into a universe where more and more regions are and will remain silent. They travel on anyway into a darkness that does not answer back, tracing out a story that from most of the cosmos will never be heard. But let me tell you something slightly strange. We've been talking about a universe that is patchy and lumpy, full of bright knots and dark abysses. For a moment, I want you to gently set that picture aside. Imagine a universe where matter never gathered into anything at all. No clusters, no filaments, no voids. Just a perfectly even fog of particles, spread out with almost mathematical stubbornness, the same in every direction, at every point, at every scale. In this universe, gravity still exists, but it has nothing special to do. There's no slightly denser region to tug a little harder, no tiny advantage for one place over another. Every direction looks exactly like every other direction. So the pull cancels out everywhere, all the time. So there are no galaxies, no spiral arms curling through space, no giant elliptical swarms slowly colliding. There are no stars, because there are no clouds to collapse. There are no planets, because there are no stars to circle. There are no black holes, because there was never a place for matter to fall inward and stay. If you stood inside that universe, and of course you couldn't, because there would be nothing like you, the sky would not be a sky at all. No points of light, no Milky Way band, just a uniform glow, the same faint brightness in every direction, like being inside an endless, featureless fog that neither thickens nor thins. It is not empty in the way our voids are empty. There are no big bubbles of nothing between structures, because there are no structures to begin with. The emptiness here is quieter, and in a way more absolute. What is missing is not matter, but contrast, not particles, but pattern. Think about what that means for stories. In a universe like that, there is no place to call a beginning, no special region where something interesting can slowly unfold. There's only repetition, the same density, the same temperature, the same view forever. It's so simple, it's almost funny, and also a little chilling. Here's what we do know about our own world. The same basic laws acting on a slightly uneven beginning a very long time ago did not choose that smooth, uneventful fate. Tiny differences were allowed to grow. Dense regions became brighter and hotter. Thin regions relaxed into darkness. Filaments and walls formed. Between them the voids deepened. Out of that contrast came complexity. Galaxies, stars, planets, chemistry, life. Someone lying awake at night, listening to a video about the darkest places in the universe. The bright parts give you warmth and detail. The dark parts give you distance and scale, and that strange feeling that the story might go on far beyond you. So when you picture those vast cosmic voids, they are unsettling, yes, but they are also a sign that our universe did not settle for perfect sameness. The very hollowness between the structures is part of what lets any structure exist at all. And all of it, the light and the dark together, is what makes this cosmos capable of telling rich, sometimes terrifying stories. And the deepest of those stories waits, not in the smooth universe that never was, but in the real one where the voids keep widening around the islands of light. Once you notice those widening voids, there's a strange question that comes up almost immediately. Why did we meet the monsters made of gravity before we even realized the universe was full of caverns of almost nothing? Let me tell you, part of the answer is that black holes are terrible at hiding. They are supposed to be the things that swallow light, the places where even photons cannot escape, and yet the regions around them are some of the brightest beacons in the sky. When gas falls in, it doesn't slip quietly across the edge. It piles up into a whirling accretion disk, crashes into itself, heats to millions of degrees, and shines in X-rays so intense that you can pick them up from halfway across the observable universe. Think about what that means for someone building the first space telescope. You point an X-ray detector at the sky, and there they are, violent flashes, flickering sources, jets of matter moving at almost the speed of light. You track the motion of stars near the center of the Milky Way and see them whipping around something invisible, moving so fast that only a dense, compact object makes sense. Later, you listen with gravitational wave detectors and hear two black holes collide, the fabric of space itself ringing like a distant bell. Black holes announce themselves. They are loud. That loudness made them irresistible. Early high-energy astronomy was, in a way, a search for cosmic fireworks. Anything that flared, pulsed, or exploded was a natural target, and all of it fed the popular imagination. You could draw a black hole on the cover of a book. You could tell a story about falling in, about time slowing, about being stretched. It was a kind of horror that still felt like an event, a drama. Something happens to you. Voids are the opposite kind of terror. They are not defined by what they do, but by what is missing. To notice a void, you have to do something much quieter and more patient. You map galaxy after galaxy, writing down positions like someone keeping a very long list of stars. Only when you step back, often with the help of a computer, do you see the pattern, filaments and walls of light tracing out a web, and between them enormous bubbles with almost nothing inside. Here's what we do know, without big surveys, without millions of data points and algorithms arranging them, the cosmic web stays hidden. Your experience of the sky, even over a lifetime, is too local. It took decades of catalogues, then simulations running for weeks, to make those voids visible as structures in their own right, not just blank background. Structured emptiness, a new kind of cosmic horror, in a way. Our fear followed our instruments. First we learned to hear the universe's loudest screams, and we gave them the name black hole. Only later, when we learned to see the negative space between the numbers, did a deeper, quieter fear arrive. The realization that most of the universe is not violence, but vacancy. And the more carefully we look at that vacancy, the stranger the next questions become. So let me tell you something that sounds almost contradictory. The darkest places in the universe, the ones that haunt your imagination when you hear words like void and boot is void, might also be the most peaceful places that have ever existed. Think about what makes most of the cosmos noisy. In crowded galaxy clusters, Stars are born in violent clouds. Galaxies collide and tear each other apart. Black holes feed and roar in X-rays and gamma rays. There are shock waves, jets, radiation, a constant background of events. A lot happens in a deep cosmic void. Almost none of that is true. There are very few galaxies to collide, almost no dense gas to crash together, very little high-energy radiation washing through space. Just a thin mist of atoms stretched across tens or hundreds of millions of light years, doing almost nothing for a very long time. If the universe has a quiet room, this is it. Imagine placing a single lonely galaxy in the center of the Botis void. 330 million light years of almost pure emptiness in every direction. Its spiral arms would turn slowly, stars would orbit the center, planets would trace out their paths, comets would fall and return. All of that familiar motion would go on for billions of years. But from the outside, almost nothing would ever disturb it. No neighboring galaxy would sweep past to pull its stars away. No dense cluster would bathe it in harsh radiation. The background sky beyond its own stars would be even darker than the night, And yet, inside that darkness, the local world of that one galaxy would feel steady, almost sheltered. If someone wanted the ultimate quiet place to think, or even just to sleep, a cosmic void is a strange but perfect example. No traffic, no phones, no nearby supernovae going off like flashbulbs. Just the slow ticking of orbits and the almost imperceptible stretching of space itself. So simple, it's almost funny, that the most terrifying emptiness is also the gentlest cradle for time. Here's what we do know right now. You're not in a void. You're in a room or on a couch or in a bed with walls and air and gravity and all the ordinary details of your life just off to the side. You're listening to a slow story about places you will never visit, in a universe that will go on long after every immediate concern in your mind tonight has faded. Some of it is going to stay abstract. You will never watch a galaxy drift alone across a void, but you can borrow the idea. You can let that image of enormous, undisturbed calm sit behind your own thoughts, the way a dark, quiet sky sits behind a single bright star. And all of it becomes a kind of backdrop, a reminder that there is a scale on which urgency almost disappears. When you think about that, the noise around you, even the noise inside your head, can feel a little smaller, a little more distant, almost as if the universe were inviting you to rest for a moment inside its emptiest rooms. But if the darkest places can be this peaceful, there's another question waiting in the shadows of that calm, a question about what happens when the peace is all that is left, and nothing new ever really begins again. So let me tell you, that question about what happens when the peace is all that is left does not need a sharp answer tonight. It can just be a soft thread that we follow back through where we have already been. Slowly. We began in your room with the phone on your nightstand, the ceiling above you, the quiet weight of your own body. You tilted your attention upward, past the roof, past the thin air, into the dark blue of the night sky, pinpoints of light. The simple, ancient experience of looking up. From there we sank toward the strangest lights of all, black holes that, for something called black, can blaze with bright rings of gas, with spirals of matter falling in, with jets that shout across millions of light years. They glow, and then a very long time from now they fade. Even these engines of gravity have a beginning and an end. Then the view widened. Those scattered stars, those violent hearts of galaxies, arrange themselves into something larger, a web, bright filaments of galaxies and clusters, like threads of light, dark bubbles in between like empty beads, the cosmic web stretching across the visible universe, built slowly from tiny ripples in the first light after the Big Bang. Inside that web, There are places where almost nothing lives. Cosmic voids, huge underfilled rooms in the universe. The Buddhist void alone could swallow hundreds of millions of light years and still feel mostly empty. A few lonely galaxies drifting, a great dark bubble between the glowing strands. Think about how many times the pattern has repeated in this story. Bright filaments, dark bubbles, lonely galaxies, expanding space, black holes that glow and then fade, over and over the same simple contrast where matter gathers and where it does not. Here's what we do know: the same laws of physics that shape the phone by your bed, that guide the Earth around the Sun, are at work in those filaments and voids. The same gravity that holds you to your mattress pulls galaxies into clusters and lets other regions thin out into almost pure emptiness. One set of rules, different rooms in the same vast house. Some of it is going to be a blur, and that is perfectly fine. You do not need to remember numbers or names or how big Booty's void really is. The story has been told once already. The shapes of light and dark have been drawn. You can let the edges soften, you can let them drift. So imagine yourself now floating along one bright filament, passing clusters that shine like distant cities, letting each one slip behind you as your breathing slows. The thread of galaxies thins, the lights grow fewer. You drift gently outward into a quieter bubble of space, into a private dark room in the universe out here. Gravity still works, time still moves, but there's less for it to do, and as the cosmos relaxes around you, you can feel your own body doing the same. Thoughts spacing out like galaxies, farther and farther apart, until for a while there's only you, the dark and the slow, patient laws that hold everything together, even when almost nothing seems to be happening at all. And then very quietly we come back from the almost nothing, back from the long, slow drift of galaxies, back to you. Right now, you're not in a cosmic void, you're in a small bright corner of the universe. A room, a bed, a chair, a train seat, some little patch of matter that has arranged itself into walls and fabric and breathing lungs. Think about the details that are touching you. The weight of a blanket on your legs, the way the mattress or the pillow gives a little under your shoulder, the faint warmth where your hand has been resting in the same place for a while. Around you, there are small, steady noises, the low hum of a refrigerator in the next room, distant traffic, like a slow ocean of rubber and pavement, a heating system clicking on, or a fan turning the air over and over again. Maybe there's a clock somewhere dividing time into gentle, predictable pieces. There's probably a tiny source of light, the glow of a phone screen on the nightstand, a sliver of street light sneaking past the edge of a curtain, a standby light on a television, a router blinking, a soft night light, holding back the dark just enough. Not much, but not nothing, let me tell you. That is already astonishing. Because if you zoomed out, if you pulled your awareness away from the blanket and the hum and the glow, you would find that almost all of the universe is not like this at all. Most of it is emptier than the best vacuum we can make. No beds, no rooms, no quiet appliances doing their simple, patient work. On the largest scales, galaxies and clusters line up in thin threads and sheets with huge empty regions between them. Those are the cosmic voids we talked about, places so underfilled that if the Milky Way lived there, we might look out and think we were alone. Compared to that, your world is overflowing. Every square centimetre around you is crowded with structure, atoms in lattices, fibres in fabric, nerves in skin, thoughts in a brain. And all of it, every last bit, is held inside a universe that does not especially care whether you're comfortable. Here's what we do know: care and meaning are local phenomena. They happen when someone remembers to charge the device, to pay the power bill, to tuck the blanket around your feet. They happen when another mind in the same small corner of space-time decides you're worth that effort. So some of it is going to be frightening, this idea of a vast, indifferent cosmos heading slowly toward heat death. But some of it can be deeply reassuring, because against that huge, silent background, the smallness of your bright, ordered niche makes it feel even more precious, not less. You can let that sink in for a moment. The universe outside your walls is mostly dark, mostly empty, mostly quiet. Inside there's warmth, pattern, memory. The darkness becomes just a backdrop, like the black between stars making the few points of light easier to see. And this is where something almost funny happens. In a universe that may end in perfect, featureless equilibrium, your best strategy right now might simply be to rest. To lie there in your little pocket of low entropy and allow yourself to feel safe for a while. Because we honestly don't know for certain how long any particular bright corner will last. But we do know this one exists tonight. And in a moment we are going to ask an even stranger question about what it means to live in such a place, in a cosmos that is mostly not like this at all. So let me tell you, that strange question we just opened up really leads to something simple, something almost disarmingly simple. The darkest place in the universe is not a black hole. That sounds backwards at first, because black holes feel like the villains of the story. They tear things apart, they hide light, they bend time. But here's what we do know. A black hole, especially a feeding one, is wrapped in an accretion disk that can blaze brighter than an entire galaxy. Jets far out for thousands of light years. Space around it is busy, noisy, full of events. Even the black hole itself is not forever. Through a slow whisper of Hawking radiation, it leaks. It shrinks. Given a very long time, it evaporates completely. For all their drama, black holes are bursts of intensity in a universe that keeps moving on. Cosmic voids are different. Think about the Bootis void, that vast underdense region, hundreds of millions of light years across, with only a sprinkling of galaxies where you'd expect thousands. If you place the Milky Way at its center, the night sky would hold so few distant galaxies that someone might reasonably wonder whether the rest of the cosmos existed at all. No roaring disks, no blazing jets, just a thin dusting of matter in an ocean of almost nothing. Most of the universe on the largest scales quietly looks like this. Filaments and clusters form a kind of cosmic web. And between those strands are the voids, tens or hundreds of millions of light years wide, where matter is scarce, light is rare, and events are few and far between. Not a sharp boundary, not a dramatic edge, just a long, slow thinning out. And in the far future, as expansion continues, that pattern only deepens. Galaxies drift apart until their light can no longer reach one another. Stars burn out. Black holes finish their slow evaporation. What remains, if our current mathematics is anywhere close to right, is a universe that more and more resembles one enormous, all-encompassing void. Not a single special region, but the background state of almost everything. That is the key contrast. Black holes are places of intense, localized destruction. They are sudden, focused, almost theatrical. Voids are the opposite. They are long, diffuse absence, a silence that stretches not just across space, but across time. No ripping, no tearing, just less and less happening until there's almost nothing left to say. Some of it is going to be a little unsettling when you first hear it. And all of it is, in the end, just an idea to sit with, not a problem you have to solve. You can let the details drift away and keep only a soft impression, a bright, busy web of galaxies, the deep, dark pools between your own small pocket of light. In the next part, We'll stay with that impression and ask what it means for you to be awake briefly in a universe that is mostly sleeping space. So stay with that picture for a moment, a bright, busy web of galaxies, and you awake in one tiny, illuminated knot of it, while most of the universe is already more like a sleeping ocean than a crowded city. Now let me tell you what happens if we turn the dimmer switch down. Not quickly, slowly, so slowly that if you tried to watch it in real time, you would never see it move. But in your mind, you can let time run faster, the way you might fast forward through a very long, very quiet film. Think about the cosmic web you've seen in pictures, those glowing filaments like veins of light threading between dark patches in your imagination. Let each filament soften at the edges. The bright knots of galaxy clusters lose their sharpness, as if someone has breathed gently on the lens. The voids between them, the dark regions like the Buddhist void, begin to swell, pushing the light farther and farther apart. Light still travels, stars still burn for a while, but the overall pattern is fading everywhere. Things are cooling, slowing, settling. Filaments dim, clusters thin, the web loosens. The universe is not crashing or tearing, it is just exhaling. Here's what we do know: on the largest scales, those empty regions win. The underdense spaces spread and merge until, from far enough away, almost everything looks like one calm, dark sea with a few scattered islands of light. In your mind's eye, let those islands grow smaller, then softer, then almost transparent. Light goes from brilliant to faint to barely there to memory. As the picture fades, notice what happens inside you. Your own thoughts, which a little while ago might have been jumping from idea to idea, begin to move the same way the galaxies did, more slowly with longer pauses between. A name you were trying to remember a moment ago is already less sharp. An image from your day blurs at the edges and blends into something else. Time feels a little looser, less like numbers on a clock, more like a long, continuous breath. You don't have to hold on to any of it. You don't have to decide what it all means or remember each detail or keep track of where the story is going next. For tonight, the story is complete enough. The universe can fade to black in your imagination, and you can stay right where you are, in your own small, bright corner of existence, doing nothing at all. If you're still awake, that's where you can gently rest your attention on the feeling of your breath coming in and going out, in and out. A tiny rhythm, almost comically small compared to the slow breathing of the universe itself, and all of it perfectly allowed to continue without your help. Some of it is going to slip away as you drift, and that is exactly what it's meant to do. You might notice even now that your attention drifts. It wanders between the image of a black hole glowing with an accretion disk, the almost comical emptiness of the Buddhist void, and something as small as an email you forgot to answer today. That is completely fine. Let me tell you, your mind is doing exactly what minds do. It moves between the very large and the very local, between the fate of the universe and the little worries that live on your pillow. You do not have to force it to stay with any one picture. You can just let the images of darkness and light pass through, like distant galaxies sliding behind a cloud. Think about the darkest place we talked about as a landscape you can visit, not a problem you have to solve. A quiet mental room, or maybe a wide empty field where not much happens and nothing is demanded of you. You can step into it when you want perspective, when the numbers and expectations of the day feel too close, and you need something unimaginably far away to loosen their grip. Here's what we do know. Compared to a cosmic void, hundreds of millions of light years across, the thing that is bothering you right now is very small. So small it is almost funny, and yet your experience of it is real, and it deserves a gentle place to rest. The idea of that huge silent region in space can give it that place, not by making it disappear, but by surrounding it with more room. You do not have to understand the mathematics of large-scale structure. You do not need to remember how filaments form or why galaxies avoid the emptiest regions. You can explore all of that another time if you like. When you feel curious, when you feel awake, when you feel like meeting the world with more questions. There's no urgency. The universe has been doing this for a very long time without your supervision. This episode can simply be something you return to. A familiar path through black holes, voids, and the slow cooling of everything that you can walk again on other nights. You might drift off at a different sentence each time. You might hear a new idea once and then never quite catch it again. Some of it is going to be forgotten and all of it is allowed. In that way it becomes a small ritual. Press play, lie down, let the scales stretch from your breathing to the Botes void, and let the immediate noise of the day thin out at the edges. Thank you for sharing this quiet span of time with something so large and so strange and so unexpectedly beautiful. Because in a moment we are going to follow the darkness one step further to a place the universe itself may be heading, and we honestly don't know for certain what that will feel like. And now, instead of taking that step, we are going to do something much quieter. We are going to drift away. All of these images you've been holding in your mind, black holes glowing with hot rings of matter, great empty hollows like the Botes void, the very long time ahead when even those structures thin out can slowly loosen their grip. You do not need to remember numbers or distances or any particular idea. You are allowed to let the entire story fade into the background of your awareness like a dream that was interesting for a while and then just dissolves. Think about how simple that is. You do not have to solve anything. You do not have to decide what you believe about the far future of the cosmos. You can just notice that your body is here in one small room on one small world, and that the universe can take care of its own mathematics without you for a while. If some of it is going to stay with you, let it be the feeling, not the facts. Maybe the memory of a dark, quiet region between the galaxies, or the idea that even in the most terrifying emptiness, there's still structure, still a pattern, still a history that began a very long time ago. The details can go, the mood can remain soft and hazy. And if you found this strangely calming or pleasantly strange, let me tell you that you are welcome to come back on another night when you are awake and curious again. We can visit different corners of the universe together. We can follow light instead of darkness, or watch how time itself stretches, or trace how someone somewhere first wrote down the numbers that let us measure these enormous distances. Here's what we do know. None of that needs to happen now. Any action you might take, subscribing, saving this for later, finding another slow, contemplative episode, can wait until morning. It is almost funny how urgent those things can feel in the day and how quietly unimportant they become when your eyes are heavy and your breathing slows. For this moment, the only task is rest. Let your body sink a little deeper into the bed. Let your shoulders release, as if gravity here is the only gravity that matters. Let your breath move in and out at its own pace, like a small tide that has nothing to prove. Out there, the universe is mostly dark and quiet. In here, you can be safe and still.